In this example, a periodic signal xt is given and we are asked to determine using its exponential Fourier series coefficients whether the signal is real valued and whether it is even. Let's solve the problem step by step. First, let's recall the exponential Fourier series representation of a periodic continuous time signal. A periodic signal xt can be written as follows. Now let's compare the given signal with the Fourier series expression. From this comparison, we immediately identify the fundamental angular frequency. Omega 0 is equal to 2p divided by 50. Therefore, the fundamental period is 50. Next, let's determine the Fourier series coefficients. From the given expression, we can see that AK is equal to j multiplied by sine of kp over 2 for values of k between minus 100 and 100. For all other values of k, the coefficients are equal to 0. Now that we have identified the Fourier coefficients, let's determine whether the signal is real valued. Recall an important property of the exponential Fourier series. A periodic signal is real valued if and only if its Fourier series coefficients satisfy the conjugate symmetry property. In other words, A must be equal to the complex conjugate of A minus k. Let's verify this condition. First, we calculate A minus k. To do this, we simply replace k with minus k in the coefficient expression. This gives j multiplied by sine of minus kp over 2. Since the sine function is an odd function, sine of minus theta is equal to minus sine theta. Therefore, a minus k becomes minus j multiplied by sine of kp over 2. Next, we take the complex conjugate of a minus k. Recall that the complex conjugate of j is minus j. Therefore, the complex conjugate of minus j becomes j. As a result, the complex conjugate of a minus k is j multiplied by sine of kp over 2. Which is exactly equal to AK. Since the conjugate symmetry condition is satisfied, we conclude that the signal is real valued. Now let's determine whether the signal is even. Recall another important Fourier series property. A periodic signal is even if and only if AK is equal to A minus k. Let's compare these two coefficients. A ka is j multiplied by sine of ka p over 2. Whereas A minus ka is minus j multiplied by sine of ka p over 2. Clearly, these two expressions are not equal. Therefore, the signal is not even. Our final conclusions are the signal is real valued and the signal is not even. This example demonstrated how the properties of exponential Fourier series coefficients can be used to determine whether a periodic signal is real valued and whether it is even, without reconstructing the signal in the time domain. If you found this tutorial helpful, please like the video, subscribe to the channel, and turn on the notifications bells so you won't miss future signals and systems tutorials. If you have any questions, feel free to leave a comment below or contact me using the email address provided in the video description. Thank you for watching, and I will see you in the next tutorial.